Next topic in the third unit is regarding to the period of accuracy of the regulator. Usually, what do you mean by period of accuracy? The period of accuracy of the regulator is the period where the accuracy is going to be expressed over a period of time. We all know the period is going to be measured in the order of minutes, hours, or days, years, etc. If the period of time is measured in the order of minutes, so such a period of accuracy can be expressed as short period accuracy of a regulator. That's what it is shown in this slide. Nextly, if the period of accuracy what we are measuring, if it is going to be in the order of hours or days, then such a period of accuracy is going to be expressed in terms of long period accuracy of the voltage regulator. So let's firstly we'll go look into the short period accuracy of the regulator. So as we had discussed, the short period accuracy of the voltage regulator, it is going to be expressed as the accuracy of the regulator over a period of minutes. So due to the change in the either input voltage or changes in the load. That means, as you know, the purpose of the regulator is to maintain the constant output voltage irrespective of variations in the input voltage or with the load. If these variations is going to be minimized because of these two factors over a period of time, so which will be expressed as period of accuracy. If the period is going to be in the order of minutes, then it is short period accuracy of the regulator. Nextly, we had already seen in the previous class regarding to the types of voltage regulators. So if you are regulating the voltage at the output, the types is going to be described in three categories: type A, type B and type C. So type A is the voltage regulator which maintains the output voltage as constant irrespective of the changes in the input voltage. Type B in the sense output voltage will be held as constant if there is any changes in the load. Next, type C means, so it is the voltage regulator which maintains the output voltage as constant instead of variations in both the input voltage as well as the load. So here firstly we had expressed short period accuracy of the type A voltage regulator. So which is expressed in terms of regulation factor and stabilization factor. So firstly we will look into the regulation factor. So with the expression itself it clearly indicates, so it indicates the ratio of fractional change in the output voltage with the changes in the input voltage. So as we had seen, the type A voltage regulator deals with the changes in the input voltage. So here the regulation factor for type A voltage regulator can be expressed as the ratio of change in the output voltage with the changes in the input voltage. V0 is, we know, it is the output voltage and Vi is the input voltage. Nextly, the stabilization factor is treated as the reciprocal of the regulation factor. So usually it is going to be expressed in terms of stabilization factor only, where it can be defined as the stabilization factor for a type A voltage regulator can be defined as it is the ratio of change in input voltage with the change in the output voltage. So usually for a voltage regulator, as we have seen, even though input varies, output voltage will be kept as constant. That means more or less output is as same as that of input. So therefore in this expression V0 and Vi will get cancelled. So finally for type A voltage regulator, the stabilizer ratio can be expressed as change in the input voltage with the change in the output voltage. Nextly, how this period of accuracy can be expressed for type B, as we have discussed. So it deals with the change in the load, that is how we are maintaining the output voltage as constant with the changes in the load. So therefore in the expression it's clearly expressed that, so short period accuracy of type B, it is defined as it is the ratio of fractional changes in the output voltage with the changes in the load. So here in the load, in the sense here we are expressing in terms of load current, that is dV0 by dA. As we all know, resistance R is equals to V by I. So therefore this expression, this sort of expression dV0 by dA can also be treated as the internal impedance of the regulator. Nextly, short period accuracy of type C regulator. So type C regulator in the sense, so it is going to be the regulator which will maintain the constant output voltage irrespective of variations in both input voltage as well as at the load at the output. So here it is going to be the type C regulator whose accuracy can be expressed as the ratio of output voltage, so with respect to the changes in the input voltage as well as the load. It is about the concept of short period accuracy of the regulator, where the period of accuracy is going to be expressed in terms of minutes. Nextly, long period accuracy of the voltage regulator. So long period accuracy of the voltage regulator, so it is going to be indicated as the change in the how far we are keeping the output voltage as constant, so for how many hours or how many days. So here we are expressing we are indicating certain parameters where what will be the change in the output voltage because of what will be the factors which influences the output to change in the voltage regulator. The first factor what we are considering here is the ambient temperature. That means specified change in the ambient temperature, in the sense if ambient temperature changes means then the output voltage tends to change. Next, second parameter is the change in the frequency. If there is any variations in the frequency of the signal, then ultimately the output will changes, so which affects the long period accuracy of the voltage regulator. Next, the third parameter which affects the long period accuracy of the voltage regulator is the aging of components, which leads to the instability of the operation. That is instability of the components. Instability of the components in the sense, suppose we had taken one resistor with the value of 10K. If you are operating the same resistance for a number of hours, the value may be deviated. Let us assume it as a 9K or 9.5K. So that what you can call it as instability of the values of the components. So it is, these are the three different factors which influences the output voltage of the regulator over a long period. That means it may take hours or days. It is about the period of accuracy of voltage regulators, which is expressed for short period as well as for long period. Nextly, the principle of voltage regulator. So basically, automatic voltage regulator consists of two units. One is the measuring unit and another one is the regulating unit. Measuring unit and regulating unit. The functionality of a measuring unit is it detects the signal and it will able to measure what will be the changes in the output voltage because of the changes in the input or with respect to the load. That means whatever may be the changes in the output because of some factors, it is going to be initially measured. It is the first task to be performed by the measuring unit. And the second task of this measuring unit is it will produce as the signal which will supply as an input to the next unit, that is the regulating unit. That means as we had seen, automatic voltage regulator consists of two units, measuring unit and regulating unit. Measuring unit initially measures the changes in the values of output voltage because of any factors. It is the first task. Second task is it will able to produce the signal which supplies as an input to the second block, that is the regulating unit. Nextly, the regulating unit accepts the input of the input signal of the measuring unit. That means measuring unit sends the signal to the regulating unit. So that signal which is received by the regulating unit consists of what will be the value of deviated. It is going to be plus or minus of the values. So how much value of voltage we had deviated. So based on that signal will be treated as the error signal. Based on that signal, so the regulating unit performs or corrects or adjusts the value of output voltage. That is, if the output voltage what we have, it is going to be decreased in the sense it will supply the value of positive. So that means with the just like an error signal, the regulating unit receives the signal. Based on this signal, so we are going to have plus or minus of the values so that the output voltage is going to be regulated. Suppose the output voltage reduces by a value of 2 volts, the measuring unit supplies the value of 2 volts. So because this regulating unit adds those 2 volts where output voltage will be maintained as constant. Suppose at the output voltage is lack of 2 volts, that is minus 2 volts. this measuring unit supplies 2 volts, which is going to be added to the value of voltage, where this based on these signals sent by the measuring unit. So we are the regulating unit adjust the value of voltage, where the output voltage should have to be kept as constant. Once again, the principle of automatic voltage regulator, basically it consists of 2 units. The first one is the measuring unit and next one is the regulating unit. Measuring unit firstly measures the values of changes in the value of the output voltage. Based on the changes, it will able to produce the signal. This signal will be sent to the regulating unit. The regulating unit will accept the input of the measuring unit. Based on that input, the regulating unit will adjust the value of the output voltage, where overall at the output of automatic voltage regulator, so the output voltage have to be maintained as constant. It is about the concept of principle of automatic voltage regulator. Thank you.